encouragement and support for organizing this event. Thank you, everyone. So now I just forward it to Rajni ma'am, my principal ma'am. Ma'am, please.
Thank you, Krishnaveni. A very good morning to all my colleagues, Professor Amarnath Reddy Garu, and the participants who are attending this program. I congratulate at the outset the Department of Civil Engineering, armed by its force of enthusiastic faculty who are ever ready to organize something or the other. Earlier it was offline, but from March onwards, they very quickly took on to the online mode and they are active, upgrading themselves, learning themselves, at the same time, creating opportunities for others also to learn. Whether it is their students or other faculty members and faculty from everywhere. I've been told that for this particular FTP, which is for a duration of 5 days, around 246 participants have registered from all across the country, and that is really commendable. Because many of these people we do not even know. I really wonder if they know the name of this institute, but maybe this is an excellent opportunity that we are able to connect with them, and probably in the future we will share our learnings with them and we too get enriched in the process. To say a little bit about our college, introducing our college to the participants, this civil engineering department is a part of the engineering and technology programs that we offer. We have three more undergraduate BTech programs, that is in the area of electronics and communication engineering, in mechanical engineering and civil engineering. This year, along with civil engineering, we are also starting MTech programs in the area of computer science engineering. All the four departments which have been started in the year 2011 are now accredited by NBA, and the entire college is re-accredited by NAC. This is a part of a larger organization called the Gayatri Vidya Parishad College for Degree and PG courses, which was started in the year 1989 with a few undergraduate programs in the area of science, commerce, and management. And today we have both undergraduate and postgraduate programs in science, commerce, management, and arts, along with engineering programs. So we can say we are truly a multi-faculty college, and we derive our strength from this, that we are able to share whatever resources we have in different departments, and that widens the perspective of learning both for our teachers and the students. And we go by the vision of this group, that is creating human excellence for a better society. To say a little bit about the larger group to which we belong, Gayatri Vidya Parishad, we have two more engineering colleges, one medical college and a school that we support in about around 10,000 plus, close to 11,000 students, and about 1,500 plus faculty in all the institutions put together. Now, regarding the FDP, I am not an expert, or rather, I'm a novice to the area of civil engineering. But I always believe that civil engineers are the people who are recognized. I remember when I was small, an engineer for me was only a civil engineer because I could see what they were creating. Even today, when we go around, we say we see a dam, we see a building, or we see a big residential complex, or we see a bridge or anything, immediately we try to think who must have constructed this. So this is a wonder which is there for the past 100 years, 50 years. I'm not saying that the other engineers do not do some equally good work, but then many times their contribution is not tangible and cannot be seen. They put in parts and pieces, probably. That's from a layman's perspective. I think many of the participants over here are with engineering background, but I'm talking from a layman's perspective. And this topic, that is trends in transportation engineering, I belong to the management department, and we talk about sustainability and development of the society. Transport and anything related to improving the transportation, I believe, is the biggest strength that the nation can build on. If you can all recollect, I think I don't have to say this in this group, but whichever part of the country has a road, has connectivity. And once connectivity is there, the livelihoods improve, the lifestyles improve, the standard of living improves. So I think whether it is road or water or the air transport and the different challenges over there, they are an evergreen field. We need to continuously evolve if we are going to create better opportunities as engineers for the society to grow and develop not only economically but socially, which is very important. We always talk about getting resources, getting return on investment, economic development, but pandemics like the present one bring us back to the ground reality that it is not always economic development which talks about the quality of life, it is social development. And I think engineers and this particular area that you've chosen, transportation, has a very significant role to play in creating sustainable society, sustainable living, and a sustainable development for the nation for years to come. I'm sure my team, the entire department of civil engineering and the others in other engineering departments have left no stone unturned to ensure that the participants have a very enriching learning experience. And I think you will continue to associate them long after this particular activity. Congratulations to the entire team. Thank you, Dr.
Thank you,
Raja
ma'am.
Garu, Director, for being a support to them, and the Vice Principal, Professor Sarita. Thank you, Amarnath Reddy Garu, for joining us in this inaugural session. Thank you so much.
Thank you, ma'am. Thank you for your. Hello,
Yeah.
ma'am. Can you hear me?
Yeah, I can hear you. Have you lost me? Can you hear me? Continue.
Yes, ma'am.
Mansa's
Ma'am,
lost.
thank you, ma'am.
Mhm.
Answer, ma'am. Can disconnect and thank you, ma'am.
Ma'am,
Mansa
Josna,
has
ma'am,
lost.
continue, please.
Yeah.
Okay. Thank you, ma'am. Now I'll give a small brief on our speaker, Professor Amarnath Garu. Professor Amarnath Garu is currently in IIT Kharagpur. His area of specialization is transportation engineering, and his special interests are structural evaluation of pavements, sustainable concept in pavement materials, and pavement design. He has totally 26 years of academic and research experience, and he published 65 technical papers in international, national journals, and conferences. And he has sponsored a research worth of 350 lakh apart from several consultancy projects in pavement engineering. And apart from this, he was a principal investigator for the project Network Center on Highway and Airport Pavements, sponsored by Indo-US Scientific Forum. And currently, he is sponsoring. He has two sponsored research projects from NHAI, Government of India, New Delhi. And till now, he has guided 3 PhD students, and again, 6 students are under his supervision. And has contributed in the revision of Indian Road Congress IRC specifications, IRC 37, IRC 58, and in the formulation of IRC specifications for IRC 115 2014, flexible payment overlay design methodology using falling weight deflectometer technique. So with this short note about the speaker, I request Amarnath sir to please continue start his presentation. Thank you. Sir, Amarnath sir.
Thank you very much. Okay.
Thank you, sir.
I'm okay. Yeah.
Sir,
Yeah.
sir, please on your video, sir.
Okay, we do. Yeah. So Yeah.
Yes, sir. We could see you, sir.
Maybe you can share the screen probably.
Yes, sir.
This, I mean, so that I can go to presentation. Yeah.
Yes, sir. You can go to presentation. Sir, Paddu, sir.
Madam, చెప్పండి.
Share screen share.
Sir is sharing.
So,
సార్ మీరు షేర్ చేయొచ్చు సార్. Beside this voice icon, you have an up showing arrow, sir.
Yeah, that I share. Yeah, I have to click
Yes,
it.
sir. Using that, you can share, sir.
No, okay, let me see. Am I visible now?
No, sir.
Your screen is
No,
visible,
my-
sir. Your screen
Visible,
is
na?
visible.
Okay, fine.
Yes, sir. Yes, sir.
It's visible, na? Okay.
Yes,
Yes,
sir.
sir.
It is visible, sir.
Okay. So, okay. So, good morning, one and all. Okay. So, at the outside, I would like to thank, of course, the Gayatri Vidya Parishad for, of course, giving this opportunity to speak to the mostly it's the faculty, no? Am I correct? Participants mostly are faculty
Yes,
or
sir.
something?
Yes, sir.
Everyone.
All faculty, sir. Everyone is a faculty, sir.
Okay, faculty, good.
And
so,
we have some industry people also, sir.
good. So, okay, not students. So, I'll be, of course, talking about the one particular aspect. Okay, that is the structural and functional evaluation of payments in India. Like where we are standing today, and what are the challenges and opportunities. So my topic, of course, will be oriented towards where we are standing today in India and what we can do in the college levels. Maybe I'll use some kind of ideas for faculty to take up some kind of a maybe projects local level like BTech or even MTech or something like that projects, yeah, or even research also, some of the areas. Of course, this is a very confined area, of course, very right now has got a lot of potential also because of the, I think all of you know, I need not say about the investments that are being poured into the road sector. Okay. So keeping that view, so I'll be delivering my lecture. So since, of course, some of them, most of them may not have background of payments, maybe they may a little bit. So I'll be talking in general, then I'll come to the research components here and there. Okay. So as my topic is on functional and structural evaluation of payments. So let us understand what is a functional evaluation means. So functional means it is something like to do with the tops or surface, what we call it a surface layer of a payment, okay, or top surface of the payment, that is the various characteristics or parameters. So these are later on I'll come to the essential why these are important. The second one is structural. So all of you know that structural means a load carrying capacity or load transferring characteristics or parameters. So these two are important. Okay. Apart from building a good quality of roads, so we also need to, like, one is of course the first one is very much demanding for the users. Okay. The second one is for the designers or the people who maintain the infrastructure. Okay. So the civil engineering structures, okay, that it be any building or historical monuments let it be bridges, dams, steel structures, roads, even the quality assessment of concrete, okay, water tanks, whatever like you can call it as. So the assessment is very much essential. Once we build a building or once we construct a dam, okay, we need to know the kind of the current status of that particular structure, okay, in terms of functional and structural. For some of the aspects, undoubtedly structural aspects are very, very important. That is, load carrying capacity is very much essential. But for some, even the functional aspects are also important. For example, of course, building, if I come to building, so building, the functional aspects may not be that important, but of course, for some people, even that is important. Suppose you want to sell a building. So if the structure is sound, but functionally, that means it is like faded away, there's no painting, and it's like some things are gone. So the kind of the resale value, if you want to sell it, so you may have to compromise on the price. So, but for some of the aspects, like for roads, for example, if I call it as for roads, the functional aspects are very, very important. Unlike building, where even if a structure is sound, inside a building, if things are fine externally, I don't care if I'm not selling, it's fine to some extent. But roads and other infrastructure, it is not so. So thereby, people started assessing the quality of the quality. I mean the kind of the assessment. Okay, people started doing this. So initially, when things were not there, so people started using visual. Even today, also visual things to great extent they are useful, but visual is always not. You cannot able to figure out with visual things. Okay, vision is to some extent it is helpful. People started then using some kind of mechanical devices to assess the quality of like whatever like facilities, like whether structural or functional. But today, everything gone. Like of course, the front seat is by sensor based. Okay, lot of sensor based things have come up. Sensor based devices, whether they are either embedded into the system or they are just attached and taken out. Okay, and a lot of the ancillary systems are available to monitor the in situ behavior of any structure. So today we are talking about work from home. So this is very much relevant. I mean, it is being practiced here. Like you can monitor the quality of a concrete. For example, a concrete is being poured in a multi-storied building, or a concrete is being poured in a road construction. So you don't know what kind of quality of concrete that is being poured, or how much amount of concrete has been delivered. Okay, so all these things can be monitored by sitting in an office. Only thing is you have to embed some kind of sensors and monitor, okay, from home. So this, of course, this is not a new people are using, but only thing in India, we have not come to this kind of extent. Like for example, quality of concrete. Okay, can you really assess the quality of concrete if some concrete works are going on? If you can do that, okay, then of course there is a lot of even improvement in the quality of construction that is being. Anyway, I'm not going to that kind of point. So that means the monitoring. Okay, the monitoring is now extended its arms. You can think of monitoring any kind of activity, civil engineering. I'm talking about civil engineering things, and it's nothing but integration of hardware and software like sensors. There are a lot of data system today are available. Then you can analyze. Then of course, when it comes to some kind of decision making, you have predictive models available. With that models, you can think of, see what is the status of that particular structure or any kind of a facility. Then you can take a decision whether I should demolish this or I can rehabilitate. So what kind of rehabilitation that is required? Everything can be done once you can monitor any structure. And why this is important? So as all of you know that we have to give a cost-effective solution. See, money is not available plentifully. So money is always an issue every time for any country. So you have to take a proper decision okay, on what is the level of this particular structure, where it's standing. So thereby you can think of a effective rehabilitation measures. Thereby you can reduce the operating costs of that particular structure. Otherwise, what happens if you leave it, one day you may have to demolish that kind of a structure. So once I do this on a regular basis, so I can increase the safety, and then also I can increase the reliability of that particular kind of a structure. So now I'll just switch on to my topic, that is called payments. All of you know that. So health monitoring of these payments is very much essential. Maybe I can call this particular thing is compared to any other structure, this will deteriorate very fast. Okay, very fast. Payments deteriorate over time. If the traffic is very high in the sense, if the traffic is of overloading, okay, what you have projected and what is actual, if they are different, so things will deteriorate faster. Climatic conditions, rainfall, heat, all these things which you cannot avoid, so they will also contribute or add to the deterioration. So even a payment which is left out, somebody has constructed, you just leave it, no traffic on that, even these payments are also going to deteriorate. Only thing is, rate of deterioration will not be that faster compared to the payments which are subjected to traffic. So all payments deteriorate over time. So thereby you need to, of course, know the kind of current status of those kind of payments. Of course, somebody can okay, there is a visible cracks. Okay, now okay, fine, cracks are there, fine. Cracks means what kind of level of cracks? It is subjectivity. So with these cracks, so what kind of riding quality you get it, and what kind of vehicle operation cost it is going to get. So all these things are okay. You can see the cracks. Undoubtedly, yeah, cracks, of course, are the, I mean, some of the that indicates the deterioration, no doubt. But you need to know the what level of cracks and what is the effect of these cracks. Cracks is only one part of I mean one failure, but there are other failures which are also there, and you cannot really estimate or establish how these are going to affect the riding quality or the vehicle operation, etc. So thereby you need to evaluate the functional aspects. That means the top surface quality as well as structural condition like load carrying capacity. Both need to be done. So we say in payment engineering that the payment should not fail functionally and also should not fail structurally. So even suppose the payment is very strong, it can take loads, but the functional aspects are gone. For example, I'll give an example where the payment is having very poor skid resistance. Friction is very, very low, very, very low. Everything like glassy. So what happens? It becomes very unsafe to ride over that, especially on a rainy day, because you have a water film, you have problem of hydroplaning. So all these things will safety issues. So even everything is fine, no cracks, nothing, but only thing is the skid resistance. So thereby this skid resistance is one functional aspect or one parameter of a payment. So now the present situation in India is we are constructing several highways. I need not say that for the last 2 decades we continue to build maybe from 2-lane to 4-lane, divided 4-lane to 6-lane, even expressways. Okay, you have got even freight corridors are coming up, dedicated freight corridors are coming. So like a lot of developments are happening. Now this infrastructure, once we create, okay, we have a, okay, we are even trying to remove the bottlenecks on the major highways through Bharatmala, the recently launched project. So once we do this, and even these payments are going to deteriorate, you need to manage these payments. Okay, so the payment management system, PMS, is the next emerging area in payment engineering, where all this infrastructure which you have created, okay, see the rate of creation of this infrastructure will not be there after 20 years. After 20 years, you have almost reached, I cannot call saturation level, but you have reached to the greater extent what is required. Then it's only managing the assets. Like for example, US, what they are doing, there may not be any new highway which are being built up in US. Only thing is the assets which they have created long back, now they are managing efficiently. So this payment management systems will take a lead role. So this payment management system is nothing but of course, that requires the functional and structural evaluation. So as I said that from user point of view, riding quality is very important. That means safety is important and speed is also important. So I cannot say that if the payment is undulated, okay. So where I know that I cannot move with the greater speeds for which it is being designed. 100 kmph is not possible on national highways if is riding quality is poor. Then even if I try to go with that, so a lot of, what happens to the vehicle get damaged. Even I have a fatigue. I experience a lot of fatigue. Okay. And even sometimes it may lead to safety issues also. So from user point of view, user always requires good riding quality. Thereby he can ensure safety and also he can maintain speeds. So thereby to make sure that the riding quality is ensured, safety and speed is ensured. So we need to maintain this infrastructure. Okay, I need not emphasize on that. So thereby, and as we are developing and upgrading a lot of national highways and state highways in the country, so this particular subject got attention, like greater attention in the recent times. So how it is there? For example, if I just open any NHAI website where NHAI is responsible for developing the road infrastructure in India and then under the umbrella of Ministry of Road Transport and Highways. So you can see that when you want to rehabilitate, that means you want to existing payment, you wanted to go for rehabilitation, that means improving, upgradation. They always say that you have to do this kind of things. You can see that a lot of facilities are required. I'll just come to this. Okay. So even see where, for example, one of the surface characteristics, as which undulations, is nothing but roughness. Roughness. I'll come to definitions a little bit later. See, for example, a roughness has to be carried out using a network survey vehicle. So that is what that means, which has got a laser profilometers. So when I want to do the functional evaluation, which is roughness, is one of the important parameter. So I need to do with a network survey vehicle, which has got a facility of laser profilometer. Similarly, when I come to strength point of view, strength characteristics of existing payment, whether it can take because already I have constructed 5 years old. Now, whether really it can structurally take, whether it has got a load carrying capacity or the life of the payment has comes to an end. How to know that? So for that also you need to do some kind of evaluation, which is non-destructive evaluation, NDT. So using an equipment called FWD. Anyway, I'll just come to this a little bit later. So for example, you can see this is what I have just taken from their request or proposal. They said that, okay, please do these are the two, just see, these are the first three, 1, 2, 3. They belong to first 1 and 2 belongs to the functional aspects of a payment. And the second one, the third one is the structural aspects of a payment. They say that every year you have to do here, once in a year. And here you can see twice in a year, the payment, existing payments, which are of course are under this project. So need to collect some data which is related to the surface defects of a payment and also the road roughness. Okay. So thereby today, there's a great demand on this. So every consultant or every organization, like whether state government or central government under whom these roads are like, authorized to, develop and of course maintain. So they have to ensure that these kind of studies are done, and based on that, they need to take some kind of a decision. Okay. So now, with this background, I'll just come to this functional. What do you mean by exactly functional performance and structural performance? So functional performance means ability of the payment to provide comfort, safe, economical riding surface to the users. So this is something related to the top surface of the payment. We call it as a wearing course. So in our terms, we call it a wearing course, which is the top surface. So this can be measured by how to measure this. Okay. People start, how do you measure this functional performance? So there are a lot of indices available. One is called present serviceability index, PSI, and also there is another term called present serviceability rating. I can rate the payment, PSR, okay, between 0 to 5 under scale. I can also evaluate by skid resistance, okay, how much skid friction is being offered. I can also evaluate in terms of roughness. That means undulations of a payment structure which is there. So this PSI and PSR are the terms which have been, given by ASTO, which is one of the first ever road test facility. Road test facility that has been created in US. So they constructed several payment sections in US in the way back in 1950s after Second World War, because all the payments were badly damaged. So they want to understand the material behavior for different loads and climatic conditions. So they constructed several sections. A lot of studies were done. So that was a landmark for development of payment engineering. So there they have come out with kind of parameters called present serviceability index, PSI value, which is a function of several functional aspects of a payment, like roughness, cracking, patching, etc. And also they also came out with the rating also, PSR. I'm not going to discuss about that. So you can talk the functional aspects of a payment in terms of the serviceability index, which is a functional diseases that we see on a payment. And we can also measure it by roughness and skid resistance. Similarly, when you come to structural performance, it relates to structural soundness, the ability of the payment to take load. Okay. How you can measure this? You can measure by, again, this is a concept which is again developed in US, structural number. That is a one number which gives the load carrying capacity of a entire payment, SN. Or if we don't use SN concept in India, we use different kind of concepts where, or in terms of any response of the payment to the product. So that means response in the sense when I apply a load to the payment structure. So there are a lot of stresses which are going to develop. There are a lot of strains, there are deflections. Okay, so I can measure some of these things, and based on that, I can assess the structural condition of the payment. So that is also possible. Okay. Now, so the one and most important parameter in functional aspects is the roughness. So roughness, road roughness. So it is it's a cumulative vertical undulations. Okay, cumulative vertical undulations. It's expressed in terms of some kind of a convenient index. Okay, some kind of a value that reflects the user's response. Like, because these are, I just told you, roughness. A person is going to get experience with this roughness. Suppose if the road has low roughness, no roughness, let us say. Of course, impossible to construct a road without roughness, but it will have some kind of roughness. But of course, finally, the user gives some his response for a given road. Okay, while he is traveling under a standard conditions. Okay, suppose a person is traveling at what speed? Suppose it's a function of speed also. So it is nothing but measure of variation of a surface profile of a road, and also the surface defects, surface diseases that have influence on the riding comfort. So now, how to measure this roughness? Okay, this is one of the very important applications in payment engineering. So normally what we do in India is we measure these by an equipment called bump integrator. And we can also, there are a lot of, I can just show you later on. This is a vast kind of subject which is already developed. Of course, I'll tell you even what we can do here. Okay. So bump integrator is very commonly used device, and there is another device where the units are mm per kilometer. There is also a Merlin, that is a measurement of road roughness using low-cost instrumentation. So there's an index which they say the dispersion in terms of and also there is a very convenient unit of international roughness index, IRI, which is a very common thing. Every country. Internationally, you can, if you express your roughness in terms of IRI, anybody can recognize. But if I express in terms of bump integrator, only some people of the country or some countries only can understand. I'll tell the reasons why it happens. So then what is meant by roughness? Okay, ASTM has given a definition. It's a deviation of payment surface from a true planar surface with characteristic dimensions that affect vehicle dynamics, riding quality, dynamic loads, and drainage. For example, longitudinal profile, transverse profile, and the cross slopes. So if these are these differ, okay, these, if the longitudinal profile differs, transverse profile also differs, then it will be some kind of deviation, okay, from a true planar. That means you should have some kind of a reference with reference to that, so how your longitudinal profile or transverse profile and cross slope are going to vary. So this is nothing but a roughness. Okay. Now, roughness, as I said, that it is to be defined over an interval of a profile. So that means roughness either per kilometer or per 100 kilometers or per 100 meters, 10 centimeters, or even 2 centimeters. So that makes a difference. So that means it's nothing but summary of deviation that occur over an interval between 2 points. The 2 points can be, as I said, that 1 kilometer, 100 meters, 10 kilometer, even 10 centimeters. So thereby, what happens is the roughness values which I am going to finally give you, they are not unique. That means not all types of roughness are unique, because if I measure, okay, with one instrument, okay, and at different periods, I may get different values. If I use different instruments itself, okay, where the reference points, the interval between 2 points are going to vary. I'll show you later on. See, some instruments measure roughness in 250 meters. Some instruments measure roughness in 400 meters. Some instruments measure roughness in 1 foot. 1 foot, like roughness, like these are the two reference points. One at 0, another is 10 centimeters. Next, 20 centimeters, 30 centimeters. So this will make the roughness values different. So many of the roughness indices that have been calculated from profiles are so strongly correlated that one is statistically sufficient. So the statistics also comes into picture when you are finally giving you the roughness values, because of the facts that they have some kind of deviations here and there. So finally the roughness indices will be calculated based on the some kind of statistical, simple statistical that work that they're going to do that. So if you see the overall roughness measuring devices are plenty. Yeah? So they have been classified into 4 groups: class 1, class 2, class 3, class 4. And the class 1 are precision profiles, like laser profiles, non-contact, lightweight profiling devices. Okay. So I'll show you some of them. You have plenty, hundreds of reference devices are available. Like each country and each university, in some of the universities, they have developed their own roughness device. Because as I said that you can measure this roughness, okay, with reference to a true planar, okay, you can measure that, and thereby you can develop any kind of instruments. And finally, of course, you can convert them into to one unit. Like for example, that's what International Roughness Index means. Like means all the roughness equipments that you have developed, so should be can be converted into IRI values. Anyway, I'll just come to that later. So you have class 2, class 3, and class 4. See, class 4 are, you can see that these are all just rating systems, visual inspection, rod and level survey. These are very simple things. So class 4 are very subjective in nature, but when you go from class 4 to class 1, so you get a class 1 is very professional, very professional, precision profilers which are there. We can see what are the things which we are using currently in India. So one of the instrument, you can see that in class 3, we have an instrument called Merlin. So this is a very simple instrument where one can try in the college levels also. Merlin, it's very cost effective. Of course, they have its own advantages and disadvantages. So very simple, low cost roughness measuring devices. It gives an index characteristics of variation of a profile of a road along the path that is considered. So very slow, not suitable for evaluating long stretches. Okay, but very important thing is this instrument, because it's a mechanical device, there are no electronic gadgets or no any other measuring devices other than mechanical are present. So it is normally used to calibrate the other roughness devices which are available. They are under type called response type. Say response type are, you can see that the same like roughometer. You can see that roughometer. So this Merlin can be used to calibrate some of the roughometers like roughometer, TRL bump integrators. So these can be calibrated using a Merlin, which is even the Indian Road Congress IRC. which is the guideline that we normally follow even for measuring the roughness. So they also said that you need to calibrate the fast moving devices, the bump integrators with Merlin. So Merlin, like this, we measure like a profile. So we have a 2 legs. This is called a reference points. So you have 2 legs, okay, and the distance between is 1.8 meters, and you have a probe here. You have a probe here. So this probe will the profile of this pavement, like when I put it here. So with reference to this imaginary line, So how much this imaginary line joining the foot 1 and foot 2. These are the reference points, and how much the pavement has is deviating with respect to this imaginary line. So that is called mid-chord deviation. This is not the but roughness. So when I move to the next point, so I will maybe another 1.8 meters. So there also I'll place this probe. I'll show the figure also. Then you can find out what is the mid-chord deviation. Suppose if there's no deviation, if this profile is here, like just if the pavement is something here, so it is truly lying on the imaginary line. So there is no mid-chord deviation. So yeah, this is what the figure is. Like you have the front leg, you have a rear leg, okay, and you have a probe here. Okay, this probe, and this is being connected with a moving arm, and there is a pointer, and you place some graph sheet on this, and the deviation, this deviation is being reflected here, and you wherever this point is shown, so you mark a point, and you continue to measure the this kind of roughness using with multiple number of times. That is statistical. They say that you have to measure 200 points in a given pavement. Okay, so now this is a Merlin, is a cycle tire, and one can fabricate very easily in the college. Very simple. Of course, manual is available. This is developed by TRRL, that is Transport Research Laboratory, TRL, in UK. Long back, very long back. So still we are using. You can see this is the probe. Of course, I do not have the full figure here. This is a probe, and this is a moving arm, and there is an indicator here. So the indicator will show the deviation. Okay. So I have so normally you have to take 200 points. Okay. Now this 200 point, like this is let's say graph sheet. So when I place this on one so normally we measure this on wheels will move. So if I place this thing, and it's a probe is let's say here, and correspond to that, the indicator is showing here the point. So you mark a point here. So when I move it to the next point, I lift this with the handle. I move toward this side. This is a cycle tire. So I can take next level and place it. So I know then with reference to this is the first point I made it. No, next the circumference, one circumference of this paddler, I'll move to the next point. So what I'm doing is I'm measuring the roughness at an interval of one circumference of a wheel. So that is my the reference kind of a thing. So that means first point I'm going to place this the rear foot, the second point here. So that means the cycle tire will move to the one more like revolution. Okay, like that. So I'll take normal 200 measurements. So then I plot like this. Okay. So 200 points will be there. So ideally, if every point is here, like 200 points are only on this, I say that pavement has zero roughness. That means, but dispersion is very, very less. But if the points are dispersed like this thing, like dispersed, so I need to take only 90% of the points. That means I have to leave 10 points here, 10 points this side. That is what statistically, when this method was established or standardized, they said that you have to take only 90 points. So that dispersion will give you the roughness. So the D, more is the D means more is the what do you call the roughness. Less is the dispersion. Like D value is say 10 mm. That means all the points are clustered here. That means roughness is very less. But the points are spread over the sheet, then you can say that higher is well. For example, dispersion is 100 mm. 100 mm means the pavement is really having higher roughness value. So, and then of course, people have also given some calibrating equations. If you can convert this into other indices. As I said, that a lot of equipments are available. So you can see that I'll go back to this equipment list. So you have Merlin. So I can convert this Merlin into bump indicator value. So I can also convert this Merlin into IRI, that is International Roughness Index, etc., etc. So for that, they have given the equations. Okay, for depending on the type of pavement surface. For example, if it is a national highway, all the Indian pavements have got Indian highways, national highways have got a asphaltic concrete surface. So D is the dispersion from Merlin. So if I have D, I can get a bump indicator value. That means as if I don't have bump indicator equipment, using this dispersion D, which is measured from Merlin, I can convert into BI. Okay. Similarly, I can also, if I want to express in International Roughness Index value, IRI. So if I know the D, which is you get it from dispersion from Merlin, I can get it. I can calculate from these equations. I can calculate from. I can represent that the roughness in terms of International Roughness Index, where the units of IRI is meters per kilometer, whereas BI is mm per kilometer, where D is a Merlin value in terms of mm. So like this, the calibration equations are available. Okay. So for different pavements, you can see for BI, mostly for BI, because BI is another instrument, the bump integrator, that is called the roughness index from bump integrator value. So a lot of work has been done on this, and they have given the correlations between BI and Merlin like that. Similarly, IRI and Merlin like this. The next instruments which are very much available is fifth wheel bump integrator. So which is also one of the instrument which is, we call it as response type roughness measuring meter, RTRMM. So which is like compared to your Merlin, this is like a fast moving device where you can measure the roughness. So what we have is, this is a normally in India, I'll just show you figure. So we use this kind of instrument called bump integrator. We call fifth wheel bump integrator. The reason is there are 4 wheels which are required to drive this, pull this at a constant speed of 32 kilometers per hour. So this is a response type device. So what is there in it? You have a big chassis and there is a wheel and there is an axle. So what they do is they mount a kind of a device, small device. Okay, maybe I'll show you in the other figures. Okay, yeah, this kind of a small device on the axle. So what it does is, whenever this wheel is being driven at 32 kilometers per hour, so it's been driven at 32 kilometers per hour, the vertical moment of a suspension system of a roughness meter is measured and accumulated with the distance travel. That means, so when there is a pavement, it is being driven, let us say there is a undulation, like there is a roughness, okay, because pavement has gone, like there's a depression, okay. So what it does is, the wheel will go, but the chassis, which has got like this entire assembly has around 900 kilos, because heavy weight. So because of inertia, what happens is this axle, I mean the wheel will go down, but the chassis, other things will not move simultaneously. Okay, there is a lag. So during this lag, what happens? This is being pulled down, because there's a wire, you can see there's a wire here, this is connected. So when the wheel goes down, and there is a wire which also pulls, okay. So when it's being pulled, so what happens is this is being recorded, like how much it has gone down, okay, because it measures with centimeters. So whenever this goes by 1 centimeter down, so there is a 1 revolution, there's a attachment inside. So it just moves by 1 centimeter, and that 1 centimeter is being recorded by a recorder. There's a recorder. Suppose if the undulation has got 5 centimeters down, so this is being pulled to 5 centimeters, and that 5 centimeters is being reflected in the counter. Okay, so like this, so taking the advantage of the inertia, so the vertical movements is counted, okay, in multiples of specified vertical distance. Maybe here 1 inch, or even you can also define in terms of 1 centimeter also if required. Okay, so but only thing is, suppose if your the vertical distance is 1 inch, less than 1 inch, it cannot pick up. Suppose if you are designing this bump integrator for picking up 1 centimeter, less than 1 centimeter, if the roughness is there, it cannot pick up. For example, if it's 3.5 centimeters, so it only records as a 3 centimeters. That means 3 times the indicator inside now it is being pulled, the wire is being pulled, then only it is recorded. Suppose if it is 4 centimeters, then the 4 number is displayed. Suppose 4 inches, so then 4 times this wire pulls by to 4 inches, and that is being recorded. So then there is a display, and of course you can also connect it to a computer, no issue. And then you know the distance also, because you have got another counter which will measure the how many revolution that wheel has made. So the wheel, this wheel, how many revolutions this wheel has made, so that will give you the horizontal distance. So you can measure the horizontal distance in one counter, and the vertical movement, okay, vertical movement also you can measure and record. So once I have this both horizontal and vertical, so the vertical to horizontal in terms of mm per kilometer, so is the bump integrator value BI. So you can see that there's a guideline which is available in Indian Road Congress, guidelines for vertical unevenness of highway payments, IRCSP 16/2004. Like they say that for good quality of payments, you can see if I want to say that the payment is in very good condition, so my roughness value, if I measure through this roughness device called bump integrator, the value should be less than 2000 mm per kilometer. If more than 3000 means, I say that's a poor, it requires some kind of a intervention. So this is the one of the instrument which is being popularly used in India to measure the road roughness. But we have gone much beyond that in the recent times, that I will explain. So now, so this is a bump integrator. Even one can think of even fabricating this also. It's not that difficult to fabricate bump. It's a very simple mechanism. If you can open this and see, there's a blade, there is a plate, undulated plate. In that, it is being calibrated in such a way that if I pull, the wheel goes by 4 centimeters or 4 inches down, and it also has to revolute to that kind of divisions. That is 4. So 1 inch is being, 1 inch is being, what you call demarcated as one undulated there. There's a plate. Of course, I have not shown that figure here, but if you can open this, and it's a very simple thing. It's a mechanical kind of thing. There's no electronics things. But only thing is, it has got a, because there is a wheel, no? So it has got a dash part. Okay, oil and dash part arrangement is there. The springs are there. So that will give some kind of a suspension. So this suspension, the stiffness of the spring is going to vary, and the quality of oil also will differ. So thereby, this kind of instruments require calibration. Otherwise, what happens if this becomes very stiff? Then what happens? The response which is supposed to give, the vertical moment is supposed to give, it may not give what it was supposed to give. So thereby, you need to calibrate these bump integrator regularly. Otherwise, what happens? You may get value, but value may not be the correct value. So how to calibrate that? So for calibration, okay, you have to, there's a procedure available. What you have to do is you have to run Merlin and bump integrator at least 10 sections. You have to get these 10 points, okay, and then develop a correlation. And this correlation, what you are going to develop based on the surface. For example, if I want to do it in a national highway, I should select 10 points on a national highway, and I'll run bump integrator, and also I run Merlin on that. So I have 10 bump integrator points and 10 BI points. If my bump integrator is correct and that is not deviated, like the oil is in good condition, the springs are also are in a condition which they are supposed to be there. So if everything is fine, then if I get a correlation, my correlation, for example, for a national highway, so I should get same correlation, which has been given by after calibration like this. Suppose say I have 10 points of D, 10 points of BI. I plot a relation. So if I plot a relation, if I get this kind of a correlation, then I can say that it is perfectly all right. Suppose if the calibration is, if I am getting a different value, so what I have to do, I have to correct them. For example, if I substitute here D as 100, let us say D as 100, my BI value should be around how much it is, 873. Just now, if I D is 100, let's say D is 100, D is 100 means, okay, sorry, D is 100 means I should get a value of almost 3,473. But if I'm not getting that kind of correlation, if I'm getting BI as instead of 3,473, BI I'm getting as 5,000, means what? Means what? I am the bump integrator value is giving higher value than what is supposed to do that. So what I have to do? I have to reduce all my readings by S factor. Similarly, instead of getting the 3,473, if I'm getting only 2,000, means what? I'm under-reporting my bump integrator value. So where I need to multiply with a factor which is more than 1, which I should calculate, okay, and do that. So like this, the calibration is very, very essential. So in a college level, so this Merlin can be developed. Even bump integrator also can be, of course, this is not a new thing, but only thing in the college levels and all, these two kind of instruments can be developed and you can calibrate them and use it for local levels. Even in college level, once these equipments are like say are available, then you may even extend. I mean, this kind of works for some quality assurance. Some road is being constructed over there. You can always verify whether this payment is getting a value of less than 2,000 millimeter per kilometer or even more than that. So that kind of works can be taken up in the college level. And also, as I said, that there is another index in the Brazil in the around 1982, when the World Bank wanted to give some funding for road improvement program, and they were puzzled that how to fund these the different agencies, like especially in African countries, not for new construction, but existing payment which are badly damaged. So they don't have kind of indices where they can have some kind of a understanding of how bad the payments are. So thereby what they did was they have given a, World Bank has given a project to the one organization to develop some kind of a index called International Roughness Index. So where any other index which is being measured through Merlin or or by what you call Merlin or by bump integrator or any other profilometers, which I'll show you later, you can convert them into IRI. So IRI is the ideal roughness index. Okay, ideal roughness index, and it is a response type system of measuring the roughness in kilometers per hour through popular is found to have some kind of difficulties, because as I said that why you want to go for IRI, because the response type, as I said that, so they are vulnerable for variation in the, because of the damping, okay, because of the oil and spring and dashpot arrangement. So they may get different kind of values. So you don't have proper values. Suppose same instrument is being run on same road. Okay, one is 1 year old, another is newly made. You'll have two different kind of roughness measurements. So thereby, and also as I said that our country will use bump integrator, fifth wheel bump. Some other country will use some other instrument. Okay, some other countries uses vehicle mounted bump integrators also available, not fifth wheel bump integrator. So like different indices, you have different units. Somebody measures only with Merlin, let us say Merlin, they say dispersion. So you cannot really understand the what you call a level of roughness that is being there for a each road. So thereby what you have to do is you should have some kind of a internationally accepted unit. Okay, so thereby, So the World Bank has come out with a international roughness index. So it's nothing, there is no equipment which is there. It's a computer based virtual response system. So what they did was, no, it's called quarter car method. So there is a mathematical formulation. So that means the spring and dash part, this is spring and dash part, and this is a vehicle suspension, okay, body of the vehicle and tire, everything is being simulated, okay, like mathematical expression. They have given a mathematical expression, and I can show you that. So this is a way in which they try to simulate the vehicle response as if it is moving on a road with 80 kilometers per hour. So they calculate, this is a measured data. So they want to have acceleration of the mass of the vehicle, like all this information. Then they pre-process it, and they integrate the acceleration data, and these are some of the mathematical expressions, okay, they do. Finally, you get a IRA value. So IRA, there's no instrument available. It's like a simulation. It's a mathematical simulation which will depict the vertical undulations of a vertical response of a vehicle if it is moving at 80 kilometers per hour. So, so with IRA, suppose like this, suppose as I already told you that IRA also has given, there are some correlations available. Like for example, if I measure roughness from D, that is called Merlin, so I can have an IRA value. Similarly, I have not shown here. If I measure roughness using bump integrator, I can also convert them into IRA. So IRA is a universally accepted unit, which is a computer simulated mathematical model, which is there for easy understanding. Suppose if I say that my roughness is 5, roughness is 3 meters, this is meters per kilometer, international community will understand the roughness of a pavement. For example, 1 means very low roughness, 5 means very high roughness. Okay, like that. It goes like this. Okay. So, and that is the recent, like what we were using until recently. But now, with the this investment that are being poured in the Indian highways, now the authorities like NHA or other organizations are started asking for even higher precision type profilometers. If you see the list of the roughness measuring devices, you have a class 1 laser profilers. What we have discussed till now is only class 3, see, bump integrator and Merlin. But in the recent times, because of the advancement in the technology and the importance of the project and the precision that we want, so now government is asking for some laser profilers also. So one of the laser profilers, like laser profiler, what is this? So it is like nothing but a combination of a laser and accelerometer, okay, sensors to measure the road profile at highway speeds. Okay. So now that means what? You can have, this is like a vehicle, you have a lasers, okay, and also you have got some kind of the accelerometer sensors. So these accelerometer sensors in combination with the lasers, non-contacting, okay, so they will give you the vertical undulations, cumulative vertical undulations, okay. So this is what you can see. You have, it is also now integrated with GPS, okay. You can get the distances traveled. You can see this is a height sensor, okay. So height sensor. So you have accelerometer. This picks up the, one gives the height, okay. Suppose the vehicle is moving. So now height is varying. So that height variation, how much height variation, that is being picked up by the height sensor, and further it is being captured through accelerometer, and finally it is recorded in the computer. So this kind of devices have come up in the recent times. These are called laser profilers. So laser profilers, one of the equipment which government of India also now telling to use is network survey vehicle. So in the first slide also I showed you that in the beginning that the roughness has to be measured through a network survey vehicle. So this kind of vehicle are available in India like from 2005. So one of the vehicle has came to our campus sometime back. then we could see the demonstration of this vehicle. This is called network survey vehicle. Now, a lot of network survey vehicles are available. This is like, what is this? Network survey. So it's like a vehicle, instrumented vehicle with cameras all around, and it's connected to GPS and a lot of sensors available. So these also scanners available, sensors. It's like almost like a scanner, like it scans the payment. Not only it gives the roughness, but also measure the rut depth, which is called permanent deformation. Also scans the payment to give the other failures like potholes, cracks, everything it gives. Okay, and since it's connected to GPS, you can know the coordinates, and these cameras will also collect the information about the inventory, roadside inventory, where is the building, everything, like what is the structure, which is, where is the bridge, where is the tree, everything is being recorded. And since it's connected to GPS, okay, you can capture a lot of data. So now on the highways, okay, this also has got a laser profiler, which works with in combination with sensors and accelerometers. Accelerometer sensors are available, laser and accelerometer sensors. So it also gives the road roughness. So today, the raw data is being collected, and there is a software. Of course, this has got a software they call Data View, a software used to perform variety of post processing. Like, for example, if you want to find out the roughness, you can do that. If you want to first find out the undulations, the permanent deformation called rutting, you can do that. If you want to know the cracks, you can measure it. Crack width, everything, classification of cracks, pothole areas, everything in one go. It's only in one go now, you can record everything. So this kind of instruments have come up in the recent time. Now also, not only they came up and people are using it. Okay. Then another important application of this functional evaluation is development of a decision tool, which we call it HDM4. So HDM4 software, of course, HDM4 is nothing but highway development management tool for highways. So what it does, see, like, for example, if you want to, even I can give some examples. Like, if you want to buy a road, suppose a road is being constructed by X party and it is being used for a few years, and some Y wants to buy it. Before he is buying, he should know what kind of condition that payment is there, and when the payment is going to deteriorate beyond a particular level, and what kind of strategy required. Okay, because he is going to invest millions of rupees on that, and he is going to own for next 30 years. He should know what is the condition and how this payment is going to deteriorate. Okay, so how do you know that? Which kind of tool will give you a deterioration, and what kind of maintenance strategies that are required? So for that, again, the World Bank has developed a tool called HDM4. So today HDM4 version 2 is available. Of course, to use this, we need to calibrate. So calibration is a big process. Unless we calibrate the various parameters which are required for making a decision, to take a decision on how it's going to deteriorate and all, it's difficult to use. But however, in the college levels and all, people can use this. The software is also very, very cheap. But only thing is, for this HDM4, we need to calibrate the various decision making parameters. So we need to collect all this information like crack data, potholes, rutting, roughness. All these things have to be collected and periodically, and using a network survey vehicle. With this network survey vehicle, what we can do is, we can first develop the calibration. We have to calibrate for Indian conditions, then develop a calibration constants. And once we establish the calibration constants, then after you run this payment, then you know, I mean, when the payment is going to deteriorate, after how many repetitions, everything, you can do that. Of course, if you don't have calibration factors for Indian conditions, you can, of course, you can assume some calibration factors and start using this kind of a tool to take some decisions, and then when to invest money, what kind of maintenance is required, etc., etc. So this is another important area where colleges, this software is also very cheap. one can buy these softwares and start using them in the college levels. Of course, as I said that in order to use these calibration factors are required. For Indian conditions, we have not yet developed this calibration. But if somebody wants to develop these calibration factors and configure the SGM4 for Indian conditions, they have to take a lot of data like this for different roads, then come to calibration constants, and using those calibration constants, you can find out the deterioration, how the payment is going to deteriorate. So this is one area which not much work has been done in Indian context. So then finally, I will conclude this kind of a topic. Maybe I don't know how much time I have. Maybe a lot of people have developed different profiler graphs. So what I showed you earlier was only two profiler graphs. One is called Merlin. The other one is, of course, bump integrator. The third one is network survey vehicle, which has got a laser. But just see, people have developed several kind of profiler graphs. Several kind. As I told you, each university has developed their own profilers. You can see different profilers. You can see lightweight inertial profiler, high speed inertial profiler. Then this is something like the Trust Type California profiler. This is in the University of California. They have developed this. Then somebody like a walking profiler. There's the dipstick. Everything, they measure the roughness. As I told you, with reference to 2 points. Okay. There's a two planar with reference to these 2 points. As I told you, these points can be 10 centimeters, 1 meter, 10 meter, 20 meter. Okay. So over this period, over this length, so they'll find out the elevation of the profile or a road profile. Okay. So a lot of, so you can see the very simple walking profiler, which will work with maybe one wheel here. There are two wheels in the front. There is one wheel, and maybe this is maybe hardly 1.5 foot. So within this 1.5 foot, the elevation difference, okay, will be captured and recorded here. Likewise, I just, when I was searching for this, of course, somebody was trying to even come out with the roughness measuring based on GPS and accelerometer sensors on a bicycle mounted using smartphone. Like you can integrate smartphone everybody has on a bicycle. Only thing is you require simple accelerometers, and if you can connect it to GPS, you can develop. Just see, a person has developed and he has put an accelerometer to this cycle, and when he's riding with at a constant speed, of course, speed and all has to be standardized. At a constant speed, he's driving on a road, so he will know the what kind of undulations. So those undulations can be recorded in a smartphone. Okay, so this kind of works are also in a college level we can find. So IRI, how he has defined IRI also is been given here. Not only that, he has also developed the other tools like, because the mobile phone also can capture the pictures, video, no? So through that also you can develop, as I told you, how much cracks the payment has got, or what is the crack width, where is the part hole, where is the road hump. So everything can be captured through a mobile kind of a device. Today this is possible. So in college level, one can do that. Suppose this is what a sensor, say when he's moving on a road hump, so what kind of accelerometer will give you different kind of a signal over here. So it can assess that there is a road hump here. Okay, road hump here. So like this. So you can try to identify potholes, humps, including roughness. Okay, all these things when you are integrating your mobile phone with accelerometers. And simple accelerometers that you can. That means when students of different specialties like civil and let's say electrical or electronics, computer science, when they come together, so they can develop this kind of a modules. Now, what are the challenges? Okay, for India right now is, as I said, that you need to calibrate the different profiler graphs. For example, I have one profiler grapher. Suppose you have developed one profiler graph, profilometer. So now you need to convert them into, you have to calibrate against another existing devices. Okay, or finally you have to convert them into IRA value. Suppose you have got you have developed one equipment. So finally you have to calibrate, and that's one. The second thing is you can yourself develop a innovative and cost-effective profilers and use them in a regional or national level. So in a college level, you can develop this kind of instruments, and then of course you can always showcase them, and also you can start using them to to see the road roughness of a particular region, or even if you can go to a national level also. The third one is, I just showed you that HDM4, a lot of data is required. So country needs a calibration factors for road deterioration, road works, and road user effects for using the HDM4. So though we are now for decision making, though we are using some by default values, and these default calibration factors doesn't belongs to Indian environment. Okay, and they have been borrowed or with some assumptions people have. So somebody can even develop these calibration factors. Of course, for that, a lot of data is required. A lot of data is required to calibrate them. Of course, as I said that if you have assumed some calibration factors, then you run a payment, you get some data for a existing payment, then you put it in this HDM4, then you know how the payment is going to deteriorate, when it is going to deteriorate. So all these things will be, deterioration means threshold value, when it is going to reach a threshold value. So all these things can be known. So that means application of HDM tool for decision making, for resource allocation. That means government wants to prioritize budget. Okay, so they can use HDM4. So students or faculty can use this HDM tool maybe in a college level for some projects. Also they can develop some equipments, in the sense profilographs, and even Merlin also they can develop, or any other, as I told you, even smartphones. Maybe of course you require some kind of initiative from other departments also to do this kind of things. So that is about the functional evaluation. And coming to the next topic is on structural evaluation. Okay, I'll just go a little quickly. So structural evaluation is the other part. So functional evaluation, only I talked about the road roughness. Okay, but there are skid resistance and all, which is not good, important, but that is not being considered. But in a HDM4, even skid resistance also has to be measured. Okay, that also has got some kind of a importance in the taking a decision. Okay, the next one is structural evaluation, like the ability of the payments to take the load. Okay, now as I said, all payments deteriorate with time, and this structural health monitoring in parallel with functional evaluation started from 1950 onwards. And this is nothing but ability of the payments to take or carry the loads. Okay, and it is being measured through a different terms. As I showed, now structural number is one term, or any other parameter where the load is applied to the payment and the response is collected. So based on the response, you can know the structural ability of the payment, like how much load it can carry or how many wheel repetitions it can carry. So this structural health monitoring is required to assess the structural soundness. Undoubtedly, whether the payment is sound, that means health monitoring. Once you know, like you are like payment is in this kind of health, then you can estimate that how many years it is going to survive. In some years, I can say life. In terms of years, I can always say that how many wheel repetitions it can carry. So once I know that, okay, it's only have got, say, only it can take only 1 lakh repetitions, then I can immediately rehabilitate, a plan for overlay. So all these things can be done once I do a structural health monitoring. So in structural health monitoring, so in this what we say NDT, non-destructive testing. So what we do is we drop a load to the payment. Once I drop a load to the payment is going to deflect. Of course, the deflection bowl depends on the characteristics of the material that have been used. Not that every payment has to get this kind of a profile. Anyway, in general, we get this kind of profile. So you measure the deflection bowl. That means you measure the deflections, rebound deflection basically. That means once the load is removed, applied and removed, then how much it has got rebounded. So that deflections are different ordinates. You measure this, and out of this is one, like if I apply load, not only deflection, it undergoes, there are a lot of stresses which are going to develop, that there are resulting strains also. You can measure any one of them, but measuring stresses and strains are very difficult. So easiest way is to measure the deflection, that to surface deflection. Suppose if I want to measure deflection here, like interface between two layers, very difficult. I should embed some things and do that, but very difficult. So out of this, it is easy to measure the surface deflection, how much it has rebounded. So people have used this data to find out the load carrying capacity of a lot of information of the payment structure. I mean, health monitoring. Okay, health of a payment can be assessed using this rebound surface deflection. Okay, now for a flexible payments like bituminous payments, so I just said that you can find out the structural condition. You can also find out the elastic modulus. That is, we call Young's modulus, but we don't call it as Young's modulus here because Young's modulus is a constant for a material, but it is going to vary here. So we call it elastic modulus. We call MR value or resident modulus, and based on that, you can develop the. As I said that health is, suppose health monitoring when you're doing, if the payment is going to last for only for few repetitions, I can always propose for overlay. So overlay is one aspect. Then of course quality control. Like if I want to execute, when I'm executing some work, whether my work is going like as per the quality assurance, to ensure some quality assurance, I can also use this NDT, non-destructive testing, where I measure the structural response like rebound deflection. I can do that. Similarly, concrete payments also, I have a lot of information like concrete payments. Jointed concrete payments has got, of course, there's cracks. That means we normally give a joint so that the recesses are not going to develop. So across the joints, what is the load transfer efficiency? We call LTE, load transfer efficiency. And one of the input for payment design, concrete payment is the supporting power, that is called modulus of subgrade reaction. So all these things you can find out by conducting this structural health monitoring for a concrete payments. So a lot of, then how it has developed, say from 1950 to 2010, lot of equipments people started developing. So they are static load based, vibrate load based, impulse, and today we have got rolling. So there are 4 stages, static to rolling. So where we are standing today is, recently we have come to this level. Of course, our country has not seen this kind of instrumentation. We only had static based NDT. Then we moved to the impulse based NDT very few years back, like almost like 3 to 4 years back. And we are yet to move to the other stage. So what are these? Like we have started with the static, the load is being applied in a like static. Then we are here like impulse, and we have to go to the next level called rolling. When the wheel is moving, okay, then how the response, how the deflections are being to be captured. So based on this first method, like 1950, this was started. So we have India also, we have adapted this. There's a guideline also developed called Indian Road Congress 1997, where we have a standard procedure to find out the overlay thickness required. So till 2015, okay, 2016, we're only using this kind of method where we have a long beam. There's a method called CGRA method, where we have a long beam and we try to measure the only one deflection, rebound deflection, when the load is removed. So I'll show you a photograph. So I have a truck here, loaded truck with a standard load of 8 tons. On the rear axle, I get 8 tons. I insert this beam. Okay. Then I have a standard procedure. Okay. So only what is when a load is removed, what happens under when the load is applied, the beam is also under deflected shape because payment is on deflection, little deflected. And when the load is removed, then what happens? The payment is going to rebound. So that rebound deflection is measured through a dial gauge. Just this is a dial gauge. Okay, there is a standard procedure. Okay, available. So for this, you require a simple. This is called Benkelman. Benkelman was a person who has developed this, and there is a standard procedure available. So with this standard procedure, what we do is we have a parameter called characteristic deflection. From this characteristic deflection, I measure what is a overlay that is required. Okay, this is a very standard procedure which was there. But problem with this is like this: 2 payments, because I am only measuring this rebound deflection. 2 payments which have got same ordinate, like maximum. This is a maximum deflection. Let's say rebound deflection. So same deflection, may have different profiles. So if you have two different profiles like this, the characteristics of or the what do you call the health monitoring or the structural condition of these payments are entirely different. So thereby this method will not able to capture, okay, the health monitoring, I mean the real condition of the payment with one deflection. And moreover, load is applied statically. So actually what you should do is normally in this entire payment engineering or in civil engineering, what you have to do is when you are trying to measure some response, the load or whatever, like what you have to apply a loads which are in to a realistic sense. So in a payment, what is a realistic sense? Like unless it's a traffic control device where you have a signal and all loads are moving. All vehicles are moving with 60 kilometers or 80 kilometers or 100 kilometers per hour. So whatever you wanted to capture the information, you have to capture when the load is moving, when the vehicle is moving. Not that vehicle is stopped and apply some load or under a what you call gradually apply load or impulse load. That is not the way. So when the load is moving, not at low speeds like 80 kilometers or 60 kilometers, whatever like speeds. Okay. So if you can capture the response, in this case, deflections, when the wheel is moving at that speed, then that is more realistic. So people have tried to achieve that. So with that, what that then they have done, next stage is vibratory. So what they did when for a payment, instead of giving a static load, they applied a vibratory loads and try to capture the response of this. But again, this could not sustain because load application is not vibratory in nature. They are dynamic in nature. So I'm just going a little fast. So even people tried with some surface wave method. So this is like dropping hammer. So you drop a hammer with some kind of a load with 6.5 kg, something like that. Then there is a waves which are surface waves are generated. Of course, this is very much popular in geotechnical engineering and also in geology. Okay, to find out the quality of materials, etc. But again, this with single load and single impact, you cannot measure the because load is applied is also very little, not actually the actual load. And with these waves, only you can talk about the one layer properties of one layer, but not all the layers. Okay, it is difficult. So thereby all these methods like this was. So all these methods did not last for a long time in terms of NDT. Then come the third and most important devices called impulse load, impulse based load. Okay, after this vibrated load. So there are few instruments which called lightweight deflectometer, LWD. Then falling weight deflectometer. This is one of the most popularly used structural evaluation of payments all over the world, not only in India, everywhere. And in same family, we have got one fast moving FWD, which is same as that. But for airports, we have got another device which works on same principle, but with higher capacity, that we call heavyweight deflectometers. So lightweight, falling weight, heavyweight, all these are impulse based. Now, what is the use of this? So the first one is called lightweight deflector, very simple device. Okay. So this is only useful for measuring the NDT. This is also NDT, non-destructive testing, but only from this data, you have only, see, this is a one single, some hammer is, load is dropped, and you have a sensor here. There is a load cell, and there is one sensor which measures the rebound deflection. So this is only useful for finding out the characteristics of a single layer of a payment or maximum thin asphalt layer. For example, you have a one layer, maybe subgrade or some layer, and another only very thin asphalt layer is there. Only for that, this is useful. Or if I'm, especially I can always, believe that this particular LWD is useful for preparation of subgrade, quality control of subgrade. Only for subgrade this can be used, but any other layer above that, that means if you have another layer over that, with single deflection and with dropping small load, you cannot find out the characteristics of all the layers, like E values of all the layers, you cannot do that. So for that, you require a higher loading capacity, more sensors. So for that, for multiple layers, you have a FWD, falling weight deflectometer. Then as I said, same principle for airports, you have got another device. Now falling weight deflect is a principle. You apply a load, dynamic kind of a load, or we call impulse load to the payment, and you measure the response. Okay, at different radial distance. You have a sensors, a lot of sensors are being placed, and you drop a load of 40 kilonewtons, which is equivalent to standard axle load of 80 kilonewtons on 2 tires. And these deflections are measured, and these deflections gives a lot of information. So you'll be measuring deflections at several radial distances and do that. So a lot of applications. Okay. And one of the important thing in this FWD is also calibration. So this is a principle used. You drop a load, and then payment is going to deflect, and you have to drop in such a way that load is going to be there for only for 20 milliseconds, which is as if vehicle is moving at 60 kilometers per hour. So then capture the rebound deflections at radial distance 1, 2, 3, 4, 5, 6, 7 in this case. All these rebounded deflections are measured. Then using this information, you can do a lot of applications. Okay. So Indian experience with FWD, very few institutions had got have this FWDs way back from 1990 onwards. Kharagpur also had this opportunity to develop several FWDs, and what I'm showing is the one which I've developed, which we are using currently. And recent times, because of the requirement from Government of India that the structural evaluation has to be done not by BBD, Benkelman beam deflection, but it has to be done with the FWD. So a lot of consultants and some academic, very few academic institutions have procured these FWDs. Okay. So FWDs, Kharagpur has developed 4 FWDs, manual way back in 1992, then semi-automated, and 2 automated versions which we have developed. Of course, this we have developed on our own. These 2 we have transferred the technology to one firm, and that firm has developed, and they are marketing also. So a lot of FWDs are available around the world. These are FWDs. You can see Dynotest is one, QUB, Phonics, and other companies. There are a lot of companies which Dynotest is the leader. Of course, other companies also are. A lot of FWDs of imported FWDs are also available in India to measure these things. So this is what it does. You can see there's a loading plate. Okay, there's a load, and you have sensors, and these sensors captures the rebound deflection. And you have a laptop. Today you can also discuss about remotely. You can also capture this by sitting in office also. Okay, this information. Otherwise, of course, this instrument has to go to field undoubtedly, and then you can capture the data. Okay, so we have used this extensively for our research work here. Like for example, this is a concrete road. We have developed some short panel concrete payments for Indian roads. This is going to come in maybe next year in Indian highways. Very short panel, very small panels, in situ panels, where the thickness of these concrete panels, of course, concrete payment is reduced by 20% compared to the conventional concrete payments. Now, load transfer, this is joint. So if I want to find out what is the load that is being transferred from this slab to that slab, so the FWD is one device where we find out load transfer efficiency. That's called LTE, load transfer efficiency, through this FWD, falling weight deflectometer. These are short panels that we have constructed on NH33. Almost like 3 kilometers of such roads are constructed, almost like 4 years back, of course 3 years back, and these are successfully used, and where a lot of benefits are also available anyway. So what we do is we drop a load, we find out the surface deflection. We also measure the payment temperature during this FWD testing. There's a procedure available how to measure FWD, this testing. So there is the IRC has brought down of course, IIT Kharagpur only drafted this code. This is not a code, this is a guideline. This is called Guideline for Structural Evaluation, that is strengthening of flexible road payments using falling weight deflectometer. So there's a procedure given how to collect data. So anyway, I'm not going to discuss about how to collect the surface data because I'm running out of time. So guidelines are available, IRC 115/2014. So how to measure? Very important thing is calibration, because this also has got sensors. We call geophone. There's a load cell. We need to calibrate them. So there's a calibration protocol has to be developed. In India, of course, we don't have protocol. Of course, Kharagpur has given some protocol, this kind of protocol only, but this has to be thoroughly, of course, examined, and always there is a scope for providing good calibration procedures to calibrate the responses, like geophones and load cell, etc. And this is, of course, method that we have used. And this is a procedure where we can find out the what you call deflection studies on a national highway. Of course, this code is elaborate and this specification elaborate. And one of the inputs required is, in addition to the rebound deflection, we require a thickness, layer thickness of the existing payment, because this is done on a existing payment. The layer thickness can be found out from by coring on the shoulder portion. You can know that, but if you have historical data correctly, you can do that. Otherwise, coring is one. But if you want to avoid this coring, which is elaborate and of course time consuming and destruction to the payment, you can do by another entity called GPR, ground penetrating survey. This is a GPR. You can run a GPR, and with GPR, of course, GPR has again several applications. With GPR, you can know the layer thicknesses also. Layer thicknesses. So from layer thicknesses and deflection and temperature, so what we do is we do because we have to analyze this, because ultimate aim of this flexible payments or any other concrete payments is also to find out the elastic modulus of all the layers. So you can do this by a procedure called back calculation. This is a software basically, and this is nothing but a process of selection adjustment of the layer moduli of using any technique. It can be a optimization technique, or it can be a closed form, or it can be data search, or it can be iteration based, so that deflection computed and measured are exactly match. So Kharagpur, of course, there are different tools you can use, ANN based, artificial neural networks, or genetic algorithm, or blend of ANN and GA, or you can do the regression analysis, etc. But anyway, Kharagpur has developed one model long back. This is GA based, and that we are using. And for this software, a lot of data is required. One is that measured surface deflections and radial distances and thicknesses and Poisson ratio values, which you can assume, and the temperature. So based on that, you can back calculate the layer moduli. For example, if you have 4 layers, so what is the back calculation, how it works? This is a flow chart. Okay. So a lot of back calculation programs are available. Not that only India has this, but a lot of each university in the US has developed their own back calculation program. And with this back calculation program, you can find out the layer moduli. For example, if there are 3 layers or 4 layers, you can find out the E1, E2, E3, E4 of all the layers. So once I know E1, E2, E3, E4 layers, I can substitute these elastic modulus in the payment analysis program, and I can find out the strains which I have. These are all the see. I have a back calculated moduli. How I'm going to use it? So I have a design traffic. So based on the layer moduli and design traffic. So what I can do is I can propose a overlay. So how to do that? So there is a procedure, okay, given here. So what I do is I'll find out so let's say this is a given payment, okay. Now I know the E1, E2, E3. These are the modulus which I back calculate from the deflections. Mu1 Poisson ratio, which I can always assign a value. I know the load, I know the thickness of the existing payment. So from this, I have a forward calculation program or analysis program, which we call IIT PAVE. Again, a program which computes the stresses, strains, deflections in a payment system, okay, for applied load. So from that, I can find out the 2 strain values here and here. This is called bottom of the asphalt concrete and top of the subgrade. So using these values, so I have a performance equations. So these 2 on these strains, this is the bottom of the asphalt concrete and top of the subgrade. So I can know what is the life of the payments in rutting and fatigue modes. So this life, NF and NR, should be more than the design traffic. This is called design traffic. So design traffic, for example, this is a design traffic high I compute. Okay. Suppose I want to extend the life of this payment for next 10 years. So during the 10 years, how much traffic is likely to apply? I have to estimate. That is based on cumulative standard axle loads. So let's say it's 100 MSA, 100 million standard axles. So if I substitute the strains which I have computed from the this analysis where that the strains are, I got it because of the back calculation from the deflection that I have measured, E1, E2, E3, E4. If I substitute, if I get both of them more than 100, so I say that I don't require any overlay. Of course, if the payment is distressed, it is not because of the structural failure, but maybe from other failures, functional failure, you can have a minimum thickness, maybe 40 mm or something you can put. But if the life in rutting and fatigue is less than the desirable value, that is 100 MSA, so what I have to do is I have to place another layer over this, that is called overlay. I have to provide another overlay whose thickness I call it as H0, which I have not shown you here. H0 I have to show, I have to use H0 and I reanalyze. So if I am strengthening this payment with H0 thickness, my strains are going to reduce. Again, I am going to recalculate the strains. I'll substitute these lower values here, because if I put another layer, I get a lower strains. Because of lower strains, my life is going to enhance. So I have to do repetitively till the life in rutting and fatigue is more than 100 MSA. So if I can do that, then that thickness is the overlay thickness that is required. So this is what it has been now currently used in India. FWD is the mandatory today to find out the requirements for overlay. There are other applications from research point of view. Only thing is you should have this kind of instrument. So whether with concrete payments, because concrete payments are going to curl up because of temperature difference. So you can measure the curling by embedding this kind of devices. And during that time, you can also do the FWD testing, because the payment, like say for example, the concrete slab is curled up or curled down. That time you apply the load and see what is the response of the deflections. Okay, that you can do. That is a more realistic. So that is one application. Second application, as I told, load transfer efficiency. This we have done in a conventional concrete payment between two slabs. How much is the load that is being transferred? So that I can do. I can also do the modulus of subgrade reaction, K value. Okay, where this is one of the inputs for payment design. So that also I can do. But for all these things, only thing is you require this kind of a device. Okay, but this is what currently it is being done. So in future, of course, as it was, rolling weight deflectometer is also coming up. What is that rolling weight? This is what rolling wheel deflectometer. The wheel is moving at 60 kilometers here, 88 kilometers per hour, and there is a beam here, laser beam, and this will, of course, there is a standard load of 8 tons which is applied here, and when the load is moving at 80 kilometers per hour, the laser beams will capture the deflection. So this is being an experimental stage. So that means this is a more realistic. Wheel is moving and deflections are being captured. Rebound deflections are being captured because of the application of load. So this is being now under experimentation. And of course, some of the institutions, not very popular, but it's maybe in future, this kind of instruments are going to come. There's also one more device by, I think in Germany, they have a traffic speed deflectometers. Same principle, more or less same principle, where they use the velocity. From velocity, they measure the velocity, the wave velocity when the wheel is moving. From velocity, they calculate the deflections. Again, moving with a laser beam. This is called traffic speed. Okay. Based on velocity approach, they calculate the. So this is another device which is, of course, under the experimental stage. There is one more device, again, multifunctional experiment. Like, for example, why to have functional evaluation separately, structural evaluation separately. So everything is integrated. Just see, this is the instrument. Okay. You have a unevenness, road unevenness. This is what roughness. Okay. Now you have a laser. You can see this is what the rolling wheel does it. Okay. That means this is for the structural evaluation. You have a texture. That means skid resistance also can be measured. And in the front, you have other scanner which will do the road scanning. That is what you call your cracks, potholes, rutting. So pothole rutting from this sensors, laser beam, then unevenness from this, then a rolling wheel. These are like lasers, again lasers, beam. This will do the rebound deflection, and there's a gripper. This is a texture, skid resistance, and to know the, if you want to know the location, GPR is always ground. And this is connected to GPS, and there is also GPR. GPR, what it does, it gives the thicknesses. So you have thicknesses here, deflection, unevenness. Then what else? If you put a cameras above this, you can know the road inventory and the what is there in that. And in the front side, you can have information. So with one go, all information you can capture. This is called multifunctional measuring vehicle. So which is again in Germany and all, some of the universities are working on this, so that all the information, whatever information at both structural and functional, can be accommodated in this. Now, what are the challenges currently we have in India is, now since we have switched out from Benkelman beam to FWD, okay, as I told you, in 2015-16 onwards, we have migrated from BBD to FWD. So today, BBD is not applicable for strengthening of flexible payments in India. So there are a lot of demand that people are telling, why can't you develop a correlation between BBD and FWD? That is one. So that can be done. Okay, but a lot of experimental data has to be collected before you give a correlation. Then seasonal corrections. So in the FWD, we have given some seasonal correction, like if you do the FWD in winter, and what would be the modulus values, because you have to do FWD in a in a post monsoon season basically, or if you have got seasonal factors also, that also can be okay. But we have done based on some limited data. So the seasonal correction factors can be done for deflections. Baccalaureate analysis, the software which we told BACGA, right now we have incorporated for 3-layer system. It has to be 4-layer, and there are a lot of issues also in that, because if there is a rock in between, suppose you have a very strong layer and after that there is a weak layer, so this program cannot detect that. This program only gives the back calculation if values are going to decrease from top to bottom, but in between somewhere there is a rigid layer, suppose a concrete layer is there, it cannot perform that. So that kind of things also has to be done. Similarly, as you told, LWD, this for college purposes. LWD, as you showed, like lightweight deflectometers with one sensor and one deflection, one sensor, one load cell, you can develop, or any other such kind of portable devices can be measured, and from that you can use them for a single layer only. As I told you, single layer or maximum 2 layers, where the properties of both top layer and bottom layer are more or less same. So for that, you can think of this one. So to start with, first one, correlation between different structural evaluation tools like BBD and FWD. So we have just started this work on NH5, okay, near Rajahmundry. We have started. Somebody was collecting. Of course, we have just this is a BBD, Benkelman beam deflection, and this is FWD. Just see the QF type FWD. So both are once Benkelman beam is run, data is collected, then this FWD also went to same place and capture the data. So of course, like this, we have to do for a variety of roads before you come to a conclusion like BBD, correlation between BBD and FWD. So that's all about my talk. Okay. So almost I have exceeded by 10 to 15 minutes more. So that's all I wanted to share. And if you have any doubts, you may ask me. Okay. Thank you.
Okay, sir. So anyone, please, any doubts? Any questions?
Yeah, unmute yourself and you can ask the question.
Good morning, sir.
Good morning.
Sir, can we able to integrate this data with remote sensing and GIS, sir?
Which data?
whatever the information we are getting through the dynamic movement.
Always possible. Yeah. Always JS, GPS. Yes. You can always do that.
So can we have a constant look over on the routes? I mean,
No,
data.
which one you are telling? Which one you are talking about?
All
Structural
the
evaluation?
the deflections, cracking, all the functional parameters and the structural parameters can be able to link directly to the RM and remote sensing. That is the point.
But how to do that? I mean, in the sense, you have to collect using some devices. Then whatever application you wanted to do, you can always do that. But only thing is you have to first collect this information through some devices. That can be possible.
Nowadays, some sensors are kept near the bridges, sir.
That is bridge monitoring. Yes. Yeah. That is there. That is there.
Can be able to
see. See, even here also, if you want to do the payment monitoring, you can do that. But for that, what you have to, that's why I told in the beginning, embedded. You have to embed the, suppose I want to find out the deflections. I can embed some sensors. I can to find out some strains. I can embed and remotely I can monitor. That is also possible. But only problem with that is, if you are some bridge is like a structure which is the length is very limited, like so maybe 2 meters to 1 kilometer, 2 kilometer. But payment, suppose if I want to run, know the structural condition, 100 kilometers, okay, I can do. So I cannot embed things here 100 because very costly. I have to. But if at all I want to do that, I can do that.
Yes. Thank you very much, sir. Thank you very much for
Hello.
Sir, please talk, sir.
Hello.
Sir,
hello.
You are audible. Hello. Please talk, sir.
Hello, sir.
Tell me.
Sir, in snowfall areas, how we will detect the center line coordinate of road?
The snowfall area, see. Snowfall area because
snowfall areas, how we will detect the center line of coordinates for army purpose?
No, see, this, of course, my answer may be like this. See,
snowfall areas thickness already 1 meter or 2 meters above the road surfaces. How we will detect the center line of the road?
That is okay. See, when I want to do, see, if at all I want to do the structural evaluation, I have to remove the ice and do it only. If I want to do the, point is if I want to do the analysis like FWD or functional evaluation, I have to remove the ice and do it only. But if you want to find the, once it is totally ice, maybe you have to have some kind of other information. But from structural and functional evaluation, you have to remove the ice and do it only. You cannot do the things on snowfall areas.
Snowfall areas, how we will detect the that is laying road, how to identify if 1 meter thickness of laying on top of the road surfaces, how we will detect by using any instrument or any equipment is available?
No. That, of course, I don't have an idea much about that. But only thing is for structural evaluation, functional evaluation, which I'm discussed, you have to remove the ice and do it only. But definitely, of course.
Yes, sir. In coastal corridor roads, we are constructing in Vizag area towards Chennai. Any special features regarding pavements?
Any special features means?
Special features means tidal waters pressure applying on surface of the top of the road surfaces. At the time, what are the additional characteristics we have to apply?
No, that of course, that is materials, of course, that of course we don't have much. I mean, that kind of studies are not done in course, of course. Tidal and all, the effect of tidal, all those things on road infrastructure has not been embedded. Not embedded in the system.
That is that is a part of the coastal corridor. That is also corridor, not a golden triangle. Now coastal corridors in present.
Coastal corridor. See, basically the materials which you are going to construct now, because the materials should be all those things. Of course, if you have in the coastal areas, you have to select the materials in such a way that they resist the weathering action which is prevailing in the coastal area. For example, salts, whatever you have, no, the aggregates and other materials have to be selected in such a way that they do not by the coastal whatever like humidity levels and other than that there is no.
Okay, sir. Concrete mix. How we will prepare for the highway roads? What are the chemicals we are using? Also, if you have more time, please.
No, see, because see, concrete mix design, no, I said, like, see, normally for that we do M40 grade of concrete. Highways, M40 grade of concrete. Any M40 grade, that's what, M40 you have to use. And even in the tender document also, they give whether you can use any fly ash, all those things. But only thing is, it is M40 grade of concrete has to be used. And even the short panels which I have shown you there now, we use a microfibers, polyester microfibers, mainly to reduce the shrinkage. Okay, shrinkage. So it's like any other concrete only, but only thing is grade of concrete has to be M40, and mixed design will be done based on that only. No other changes.
Yes, sir. Yes, sir. In coastal corridors, what is the any special top surfaces, materials, or chemicals, or any other innovation features?
No,
coastal
see,
corridor
we specify like, for example, when you have high wind, what whether construction has to be taken place or not. So those things will be actually there's established rules are there, guidelines are there that you have to follow.
Sir. There is any chances discussing coastal corridors, or any discussing new more features discuss about
nothing. Quality of content, no. Quality of content.
Amarnath, can I ask one question? This is Dr. T.S. Reddy.
Okay, sir.
Okay, sir. Thank you.
Hello.
Tell me.
This is Dr. T.S. Reddy from Hyderabad.
I know.
Yeah, first of all, I must compliment you have presented very exhaustive features of the pavement, particularly functional evaluation, having so many instruments and all. But this is fine as far as the academia is concerned. How do you think, the actual departments which are owning the highways are going to handle these instruments, and then how? What is the current status? Are the NHAI or the Ministry of Road Transport and Highways or any PWD, are they maintaining these instrumented vehicles and all? Are they really monitoring?
No, they are not monitoring. It's all been given to the consultants only. As you rightly said that it's a time where they should also own the instruments and.
Unless they own it, we cannot really expect any good service for the public.
That's correct only. Because I know that some of the state governments have procured FWDs. Like even Andhra Pradesh also has procured FWD, and I don't know whether anybody is using that. But if at all they want to use it, and it's not difficult. But only thing is the dedicated team, conventional engineering. Not that they're not capable, but their maybe interest is different. So one thing is each devotee is
a task. Actually, the people have to be trained and they have to be
used. Actually,
it's an expert job. It is not.
It's not correct. Even the government of Karnataka also procured FWDs, and users are again they are not using actually. The other big point, that is one. And all these instruments require calibration. Basically, all these response type instruments require calibration. So unless we calibrate, and there should be some, as you said, there should be a dedicated team.
Yeah,
but I don't know how.
Okay, thank you.
Okay, thanks.
Thank you very much,
hello,
sir.
Sir, can I ask a question? This is
sir.
Yeah.
Hello, sir. Sir, in coastal corridors, what are the equipments we are calibrating purpose? What equipment we are using nowadays? Any 1 minute or 2 minutes, please give equipment details
Equipments means what?
in coastal corridors calibration purpose.
No. Which equipments you are talking about?
I think the gentleman should know
Coastal
the
corridors
way.
purpose, any special equipments.
No. Calibration is, see, if you have any instrument that has to be calibrated. So you should tell me what instrument you wanted to use it.
Okay.
Sir, not highways, sir, not highways. Coastal corridors checking purpose. What type of equipments? Any new equipments available? Please give information, sir.
No. There is no difference between coastal corridors and other payments. They are all same
Highways.
payment. Everything highways only. So whatever tender, whatever the government says for quality construction or quality monitoring, whatever the instrument, there is no difference between coastal corridors and other national highways. Only the materials.
Procedure is different, sir. The material is different, sir. Highways and coastal corridor material is different.
No. See, material has to. Everything is road only. Whether you construct in here and US anywhere, whether coastal corridor, everything is same. Only thing is quality of materials.
Procedure.
And any, they may ask some additional quality control checks if at all there are any. That's all. Other than that, there is nothing. No special instruments.
Sir, same layers, sir. Sir, so similar to highways, sir. So layers.
Same. See,
same layers,
is,
no additional features, sir.
No. See,
sir,
there are
side pressure reducing holes also. We are slope side pressure reducing holes also. We are providing in coastal corridor roads.
Sir, మీరు డిస్టర్బ్ చేస్తున్నారు సార్ ని కొంచెం డిస్టర్బ్ చేయకండి, వేరే వాళ్ళు కూడా అడగనియండి. Please.
You may write a mail, Mr. Reddy. Somebody write a mail. If at all we can help you, we can help actually. Okay.
Yeah, first of all, you should understand what is the problem that he is facing. Then you can suggest, what can be the solution, how you can develop the solution.
Yes, sir. Yes,
nothing will come out.
Hello, sir. This is Vijaya calling from Gayatri Vijaya Parishad. Sir, I have a small question. I have seen one presentation by a student from Amsterdam where they had a vehicle with 7 cameras. And like you said, it is a multi-dimensional vehicle that captures not only the pavement status but everything else, the elevation and the slopes and the content and the material used. Similarly, though we cannot compare to the technology, sir, the small cycle that you have shown, if we use a smartphone and a cycle and probably connect an integrator, if we want to try that as an experiment or create that instrument in campus, where do we get the technology, sir?
No. This is from the literature, like it's the integration of sensors, smartphone features. Okay. And the detailed papers I have given you, like that, a lot of papers are available actually. It's like between some hardware and software. Only thing is, this has to be, suppose if it's bicycle. So bicycle also has to make a standard bicycle. And it's also depends on the condition of the bicycle and what speed you are going to. All this has to be standard, weight of the person who is riding the bicycle, everything. But only thing, once you say that if somebody wants to use your device, you have to mention that it has to be like this only. The cycle has to be this type of cycle, the tire pressure, the person who is riding the bicycle, everything, you have to standardize. Then you can develop some correlations. Okay. But you can try. See, for example, these sensors and all, you have to catch hold of some computer science and electronics people, and you can do that. Only thing is, you are trying to measure the vertical undulations actually. And if you want to scan the payment also, you can do that, like a scanner is available. You have a data now, how to analyze this thing. Like you have got to know machine learning, many things people are using to, there's not, like, of course, in the college level, a little bit of excitement to the students. But for this, civil students have to integrate or collaborate with electronics and computer science.
They
can
should
do
give
that.
a project to
Thank you,
these
sir.
Hello.
They should give it as a project to one of the
Yeah.
postgraduate students.
Yeah. Postgraduate and even a BTech also in third year level also you can start doing. It's not that they should
The
wait
boys
for
are
final year to come.
technology, they can do much better than what we oldies can do.
Yes, correct. Because in college, no, a lot of people are there. A lot of information available everywhere now.
Yes.
Only thing is integrating
yes.
them and collaborating and motivating the students. Yeah, the cycle, you can see that cycle and it's really, smartphone. Yeah, like that one can develop. It's not difficult. Only thing you have to have some integration. I mean, collaboration with other students of the same college. Same college. It is quite possible.
Yes, sir.
And you have to do like that only. Today, it conventionally, it's not like you do the only like this. You have to integrate with, collaborate with other students.
Sir.
Yeah, other departments very easily.
Yes,
And even
sir.
they also will be excited because when the computer science person is doing a civil work, he will also be excited.
Definitely, sir. Thank you
Like
very much,
that.
sir.
Yes, sir.
Really,
Like
really good information.
Sure.
People will be told when C.V. Raman discovered the Raman effect, he had nothing with him.
That's correct.
Sir.
That's
Sir.
true, sir. I mean, the kind of
Absolutely right,
intake
sir.
we are having in the civil branch, I think they'll be more excited to the practical part of it than the conventional, the theoretical
definitely,
part in
madam.
the class.
Yes, sir.
Yes, sir.
Definitely, madam. Because this is a time where when you want to motivate the students and all, it's like integrate. Collaboration with other department, electronics, computer science, mechanical.
Ye-
The projects also should be like that. I only told these few things, but in other civil engineering, many things can be done with this kind of things only.
So we'll start encouraging multidisciplinary projects from this year on.
Yes.
Because
Even-
anyway, our CSE EC students are working mostly virtually and they are online. So the data which the civil engineers are bringing and giving, let them start interacting and make a team.
Even madam, in your college, you can make not mandatory. You can make interdisciplinary projects also. Maybe they may be
Yes.
civil and suppose computer science. They will evaluate the project. What is the problem? Like that you can think of maybe.
Yes, sir. Yes, sir. At least the good students who are welcome to any new ideas and adopting the technology, we can easily ask them to.
Yes.
Yes.
Yes, sir.
All students are good, madam. It's not that only good students. But before I leave the meeting, let me congratulate the staff of Gayatri Vidya Parishad for organizing this program. It's very nice. Congratulations.
Thank
Keep
you,
it
sir.
up.
Thank you
Thank
very
you,
much,
sir.
sir.
Thank you, sir.
And for information, hello.
Yes.
Sir.
That T.S. Reddy is, of course, is a very experienced person who is a former deputy director of Central Road Research Institute, CRRI.
Yes, sir.
Okay, welcome, sir.
but
Thank
for,
you for joining our
sir.
and he has
website.
got 40 years of.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Thank you, T.S. Reddy garu.
Thank you for joining,
So
sir.
introduce to the BTech students new chapters introduce, sir.
What that?
New topics introduced for BTech students and all that is helpful in future, sir.
That's correct only, but only thing is, see, they should fall into the university system. So we cannot,
Yes, sir.
but only special topics like this, maybe some kind of
Yes, sir.
topics which are not covered in academic area can be done. But you have to, once we introduce this, university also has to accept, na? That is also there.
Yes, sir. We are taking life period only 10 years only. In our routine 30 years, previous years, only 10 years life period only we are taking into consideration, sir.
Correct. Yes.
For near future, change the topics. Life period
That's why,
also
even
increasing,
syllabus also, yeah. But see, in undergraduate level, you cannot think of only thing, some projects and some special training or some special modules only is possible. But basics, they have to learn. That is without telling the basics. If you directly tell some software without basics, then
Yes,
also
sir.
problem actually. So it has to be like
Yes.
basics and some special topics. Maybe through different modes they can always do that.
Sir, for NBA
sir.
and other accreditation processes, we can offer such small projects as value-added courses or.
Definitely, madam.
Yes, sir. So we
Maybe
can do
now,
that. We
no,
have the
since
freedom.
now we have this online, like almost like becoming like mandatory, almost not mandatory, it becomes part of life. Few courses now you can design, maybe not in a curriculum, madam, that this kind of expert lecture, you can design some like advanced kind of things, a little bit advanced, which will motivate students, and then you can offer that.
Yes, sir. Yes, sir.
That is quite possible.
Yes, sir.
Maybe evening hours, maybe some structured kind of thing, like for civil, this one, electronics, computer science, maybe. Then you can have some kind of what you call evaluation process. Then you can give some certification. All these things are quite possible nowadays.
Yes, sir. Certificate courses are possible. We have the freedom also. Apart from the
you have the freedom.
university curriculum, we have the.
And this will know this collaborating with different specializations, madam, will definitely motivate even the student who is not very good at the studies. They will also have some kind of, suppose moment I say use smartphone, people will be excited generally.
Yes,
Smartphone,
True,
data
sir.
collection, like that I'm telling. So that will also motivate at least some of the students.
Yes, sir.
Okay. Okay, sir.
Hello. Any other questions, please? Thank you, Sarita ma'am, for coming here. Sarita ma'am, she's our vice principal. Ma'am, do you want to talk anything?
No, I just want to thank Amarnath Reddy garu. My husband is a civil works contractor, so he was also listening the deliberations in the end, in the start, and he could not move out, and he was also listening throughout. So some of the equipment, it seems, he uses in his works. He is into pile foundations. I think Amarnath sir remembers once he was asking. He is right now executing the JNPT freight corridor piling
project.
yes, sir. They are doing that work. So as on today, it is on a standstill because of the COVID rampant there in Bombay. So, but he was also listening and saying, yes, this instrument will be useful. So again, we will once the COVID is over. Maybe we will be able to buy some equipment related to national highways, which you have suggested.
No, what I suggested, that is useful. Well, the bump integrator, and you can even fabricate also. Some of them can be fabricated in college level with cheap cost, because Vizag, a lot of vendors are available, and that can be done. That will give some motivation to students also.
Sir, definitely we'll work out something with you, sir, with your help. Anyway, you have now become a part and parcel of the GVP family. You are on our board of studies also, so we will use the qualitative advices which you are giving. Thank you very much, sir, for the time and effort you have put.
Okay,
I hope the learning was carried over by all the faculty to their respective colleges. Thank you, sir.
Thank you, madam.
Hand it over to Jyotsna, ma'am.
Okay, ma'am. Thank you, sir. Thank you, sir, for accepting our invitation once again. And thank you for sharing your knowledge and experience, sir. Thank you so much.
Thank you very much. So I'll leave, madam. Thank you very much.
Yes,
thank
sir.
you all.
Yes, sir.
Thank you all.
Thank you very much.
So this is the end of today's session, sir. I hope all the participants got benefited with the talk. And let's meet tomorrow at 11 o'clock with Dr. Mukund sir talk on road safety audit. Thank you so much.
Thank you, participants.
Thank you very much.
Thank you.